So let's get started with actually review of actually algorithm. So what does it mean by algorithm first of all? So it is nothing but a step-by-step procedure to solve a particular problem. So it is just like actually recipe for cooking a dish. So you can think of like that. So to cook a dish, first you need to know the actually that particular recipe. So actually that actually algorithm actually is like that. So after knowing the actually recipe, then you can cook that particular dish. So that is the step-by-step actually procedure for solving a particular problem. And after that, after knowing that particular algorithm, that how to solve that particular problem, then you need to implement that algorithm through a program. That can be done through C or C++ or actually Java that you like. So first thing, to solve a problem, there will be a problem, and to solve that problem, first you need to have the logic or the strategy to solve that particular problem, and that is called actually algorithm. And after that, you need to code it, or you can say that actually particular algorithm that needs to be implemented through a programming language. Hmm. So that is the point here. And here is one sample actually. Suppose one problem is there, sorting a set of numbers. That is a sample problem. So here, first thing you need to, if you want to solve that particular problem to sort a set of numbers, first thing you need to have that you first need a actually algorithm to sort that set, right? So first thing you need to have one particular algorithm based on your choice. So there are some available algorithms for sorting. You actually have studied this kind of actually algorithms. Suppose there are actually bubble sort, selection sort, such kind of sorting techniques are there. Merge sort. So based on this actually sorting technique, you have to first choose one particular sorting algorithm to solve that particular problem of sorting. So after actually picking up one particular algorithm, then you need to actually implement that actually particular algorithm through some programming language. So that is the main case here. So the main point is you will have one problem first, then first you need to think of that how to solve that actually particular problem. That means you need to have that actually particular logic or the actually strategy to solve that problem. And so that is called the particularly, that is actually algorithm, step by step actually procedure to solve that particular problem. Then after that you need to code it. That's all, right? So next, move to next. So what are the main actually characteristics of an algorithm? So first thing is, an algorithm should take some input. So every algorithm should have some kind of input. Okay. So for sorting problem, an algorithm must take the input of some actually set, right? It needs to take some inputs as that kind of actually a set of numbers like that. And secondly, an algorithm must give some output, or it has nothing to do with. Okay, so an algorithm must give some output, or otherwise it has no meaning. Third point is definiteness. Definiteness means an algorithm must be properly understandable. Hmm. Actually, understandable means understandable to the programmer, because an algorithm needs to be used by a programmer. So, whatever you actually write one algorithm or actually design one algorithm, that must be properly understandable to the programmer, because that will be used by the programmer only. So definiteness should be there, because it needs to be implemented. So for actually implementation purpose, an algorithm must be properly understandable by actually every step. Hmm. Fourth one is actually finiteness. An algorithm must terminate. So one algorithm should not actually run actually that will not be like that. It will continue infinitely. Yeah, it must stop after some point of time. Hmm. So that is the case of actually finiteness. It should not be like it will run infinitely. That must not be done. And the fifth one is that is actually effectiveness. An algorithm should not contain unnecessary statements. That means, so whatever step that will be contained by an algorithm, that must be properly understandable and that will not be any kind of unnecessary statements. So every step should be actually well defined. Hmm. So it should be actually understandable that actually what it needs to be done by actually that actually particular step. Right. So these are the actually main actually characteristics of an algorithm. So these things should be kept in mind for such kind of algorithm design. So next there is actually that thing actually I have said just that an algorithm can be actually written or actually designed, so that can be done in actually any language, but that must be understandable to the programmers, because an algorithm that will be actually ultimately should be actually implemented, so that will be done by the programmer, so it must be actually understandable to the programmer. So whatever you write, that must be understandable to the programmers and whatever language you will use. So generally an algorithm that is written actually using C syntaxes. So I think you all know C programming language. So mostly we will use C actually codes, and you can write also actually using mathematical notations or actually some kind of English like words. Hmm. But mostly we will use C syntaxes because an algorithm actually that will be used by the actual programmer, and so to be understandable by the programmer you need some kind of actually C syntaxes, so you need to use C programming actually concept. So most of the algorithms that is actually similar to C code, not so much actually difference with C codes, I would say. Hmm. So, and third point is here that after actually designing one algorithm, it needs to be analyzed. That is how much it is actually efficient. Hmm. So after designing one algorithm, it needs to be analyzed in terms of efficiency. That means an algorithm should be, it will be better actually as much as it is actually efficient. So there is for every actually algorithm, whatever you actually write or whatever you actually design, that must be analyzed in terms of efficiency. So that is the main point here. And now let's see how algorithm can be designed, or you can say how to write an algorithm. So what happens here after actually end of this course? Many students said that they don't know how to write an algorithm, but it is actually shown to them that is in the first class itself, that how to write an algorithm. That means how to actually design an algorithm. So just I have said that it is similar to C codes. So here you can see there is one actually C function. So an algorithm is nothing but you can say it is similar to a C function. So here you can see there is one C program, or you can say a C function here. It is a simple C function for actually addition of two numbers. So here you can see sum, that is the actually C function here, and here it takes two actually integers a and b. Then there is int c equals to a plus b. Then it is actually returning that particular summation of those two integers a and b. So this is the actually C program here, that means a C function here. And here, based on this C code, so for this C code, actually this is the actually corresponding algorithm for that code. So here sum a comma b. So for actually algorithm, you don't need to put any kind of data type. You don't need to put, actually it is similar to C code, but some kind of difference is there. So the difference is here that you don't need to put any kind of data type in the algorithm. So here you can see this sum is actually equivalent to this sum of a comma b. There is no data type, no actually this kind of integer, that kind of declaration is not there. Just sum a comma b. Then the second statement is here, that is actually C. That is actually one kind of variable declaration. So an algorithm must not contain the variable declaration. So you can see here, this statement is not present in this actually under sum a comma b. So an algorithm should not contain such kind of statements, and there must not be any kind of semicolon. So it is similar to C code, but some differences are there. And this statement you can see. So it is same as this. So C equals to A plus B. So that is actually same to same. C equals to A plus B. No change is there. Just you don't need to put that actually semicolon here. Then this actually returns C. That is also same. And here is also one point is that you don't need to put any kind of brace. That kind of second bracket or brace you don't need to put here for actually algorithm. And the second point is you can put the step number also. So this is actually first step, and this is actually the second step. So for this case, the actually second one. So here actually the step number has been put. So that is the actually one, that means the first step, and two, that is the actually second step. So like this you can actually write one algorithm. So let's take one sample code also. So suppose I am taking one C code. Suppose I am taking one file, suppose 1.c. So suppose the code is like that. Suppose I am taking one C function, just I am writing the C function, okay. So if you know actually coding, then there will be no problem with this writing of such kind of actually algorithm. So suppose the function is like this, suppose int sum, then sum is the actually function name. Then suppose there is one actually set of numbers, suppose int a. That is the set of numbers. That is nothing but one actually array. Then the size of that particular array is suppose n. Then the function is defined like this. Suppose it is defined like this. Suppose there is int I, then suppose int j equals to 0. Then suppose there is one loop for loop is there. Then it is suppose I am writing this I equals to 0, then I less than suppose n, then I plus plus. So then there is, so actually under this loop there is one statement, suppose j equals to j plus ai. That means the set, that means the summation of that particular set of numbers. Then after that loop, you are returning the summation, that is j here. So what does this function is do? Actually, this function sum, it takes two actually inputs. So one is one actually particular array of numbers, and this is the size of that particular array. Then after that there is one loop, and it is actually doing that. It actually contains, this j will contain the summation of all the numbers from this set a. Then after that it is returning that particular summation j. So what will be the equivalent actually algorithm for this code? What will be the equivalent algorithm for this course? So first thing is, just I have said that you need to actually, you don't need to put this kind of data type. This int should not be put. So you just need to, so suppose I am taking one more file, okay? So suppose I am taking, suppose one text file for writing that particular actually algorithm. So just I am copying this. This code I am copying here on this text file. So based on this code, now I will actually write the algorithm. So what will be that? So I have said that you don't need to put this kind of data type. So int you don't need to put. Based on that code, I am writing this. N. This brace should not be present in an algorithm. So that is also actually removed. Then this int I, this kind of declaration should not be present in an algorithm. So it is also removed. Then int j equals to 0, this j will contain some value, right? So that means it needs to be present. So j equals to 0. You don't need to put the semicolon here. So that is also actually removed. Now this loop for I equals to 0, I less than n, I plus plus. So for coding purpose, one particular array that starts from 0, right? But for algorithm, it will start from 1. So that means it will be like this. This loop that will look like this. So here you need to put for I equals to 1 to n. So, so it will be like this. So that actually particular loop, this loop will be represented in algorithm like this for I equals to 1 to n. Then this statement is here, j equals to j plus ai. So here this statement will be present, but the semicolon must be removed. Then this brace will be removed. Brace should not be present here. So here you need to put some kind of indentation. So such kind of indentation you need to actually use for this algorithm. So such that it can be actually understandable that this statement under this loop. So that's why you need to put some space or some kind of indentation so that it can be understandable that this statement is under this loop. Then there is this brace should not be present here. This semicolon should not be present here. Then this return j. Okay, so these are the steps for this algorithm. So now you can put, if you actually need, you can put the step number also. 1, then 2, then it is the third step, then it is fourth step. Like this, based on that particular C code, just actually I have written that particular algorithm. So it is, so many students said that they don't know how to write. So it is just so actually simple. So if you know C code, then no problem is there, and some kind of differences that you need to know. So that is the thing here. And one more thing is that you can actually remove this kind of third bracket also here. So you can put, but it is not required actually. So here it is actually understandable. For this case, it is actually understandable that that capital A, that is one kind of set, or it is actually one kind of particular array. So like that you need to write actually algorithm. So now suppose I am taking one more. Suppose I am taking one code. Because after all you have to actually design your algorithm. So suppose I am taking one more program. Suppose it is for sorting. Suppose in sort, and it takes just like the previous one, it takes two inputs, one actually particular array of numbers A, then this n that actually indicates the size of this particular array. Then there is int I, j. This is not required actually. I think you have studied some sorting technique in actually data structures. And I also actually expect that you know C coding. So ij, that will be used for actually loop counter. Then for I equals to 0, then I less than n minus 1. Then I plus plus. Then you need to put, for sorting, you need to use two for loops for comparing, right? For comparison purpose, you need to use two for loops for sorting technique. So I hope you know this. So you may know this. So then the second loop will be for a simple sorting technique. J equals to 0, then it will be j less than n minus 1, then minus I, right? Then it will be j plus plus. Then after that, this loop will contain one condition for comparing, because you need to compare that actually for every actually numbers you need to compare, right? So it will be like this, that capital A, suppose you need to sort that set in actually increasing order. So it should be this condition will be like this: if aj greater than a j plus 1. So that is for comparison purpose. So that means if you want to sort a particular set of numbers in increasing order, then it should be like this, right? So it should be like this. This aj plus 1 needs to be greater than aj. But actually for that particular set, uh, this condition if actually happens, then you need to swap these two numbers, right? This aj and aj plus 1. So after this comparison, you need to swap or actually exchange these two particular numbers, aj and aj plus 1. So for that thing, you need to use one more actually variable to hold that aj, right? So one temporary variable is here, aj, right? Then this aj will be now will contain the value of a j plus 1, right? Then after that, for swapping purpose, this aj plus 1 now will hold the value of this, that actually aj, that means this temporary, this actually temp. So this temp will be assigned, that means the value of this actually aj, that is actually assigned to this aj plus 1. So this is that actually if block here, and so here it is, there is one, two, three braces are there. So three braces, this return is not required. here, and this third brace is for this one, right? So this is the case here. This is the, so actually which sorting technique is there? So which sorting technique actually is it? Very much simple.
The bubble sort.
Yes. So you have actually studied this sorting technique, right? So it is actually bubble sort, very simple sorting technique. So it is just the actually sorting function here, and I have written the actually particular code for that particular function. Hmm. And for that case, you can actually call this function from the main function. Hmm. Just for actually running this code or for actually complete code, you have to define the main function. Just actually I have written here the actually particular function for sorting, not the whole code. For the whole code, you need to actually define the main function also. And from the main function, you have to define, sorry, you have to call this sort function from the main. So now, based on this sort function, you need to suppose write the algorithm for bubble sort. So based on this code, now I will write the particular algorithm for bubble sort. So just I am copying this code and I am putting here this text file. Now I will write the actually that actually particular algorithm for bubble sort based on that code. So if you know that C code, there is no problem. So you need to remove that particular data type. Int is removed here. Int 10, that is also removed. You can remove this third bracket also. This brace also must be removed. Then these declarations int I j. These two actually variable declaration must be removed. Then there is one loop for I equals to 0, then less than n minus 1, then I plus plus. So here what will happen? For C code, that particular array that actually index starts from 0. But for algorithm, you need to start from 1. So here what it will happen here? It will be like this. For I equals to 1 to n minus 1. That will be converted like this. I equals to 1 to n minus 1. Then this second loop, so it will be converted like this. It will be like this: j equals to 1 to n minus 1 minus I. That particular loop that will be actually defined in this case like this. Then this if condition for comparison. So if this first bracket should not be present, this brace should not be present. So if then aj greater than aj plus 1, no problem with that. This statement is no problem. Then this case, this in temp aj, then aj equals to aj plus 1, so then aj plus 1 equals to temp. So actually what is actually happening here? It actually swapping two values, right? This aj and aj plus 1. So you can write this statement. So suppose you can write this statement also. Suppose temp equal to aj, then aj equals to aj plus 1, then aj plus 1 equals to temp. Like this you can actually write, but you can write this also. So it is actually doing the task of swapping, right? So you can write some kind of English like words here. So you can write that swap or you can write actually exchange also. Swap aj with aj plus 1. So that will be actually more understandable that to the actually programmer that you have to swap these two values. You don't need to write, actually you can write, but that is not actually so much actually required. So these braces also should be removed here. So these main 4 steps are there for actually bubble sort. So here you can see, so these are the 4 steps here. So now you can put the step number also. So these are the second, and one more thing, you need to put the indentation. That is the main point here. So that it can be understandable that this loop is actually under that first loop. And this condition that actually checking, that is actually under this loop, this actually second loop. And this swap will happen under this if block. So you must put actually indentation, or it may be wrongly understandable to the programmer. So you must use indentation for algorithm. For program, there is no problem. Actually here you can put this kind of braces. So there is no problem. But for algorithm, you need to put indentation, or otherwise it will be problematic to understand. Then that is the 4th step. So that's all. These 4 steps are required for bubble sort. So this is the algorithm for that particular case. So that is how you can write your algorithm. That means you can actually design your algorithm. So that kind of thing you have to actually practice, that how to write one algorithm. So I would say that if you know C code, C program, if you know, then there is no problem for writing one algorithm. Based on the C code, you can write your actually particular actually procedure. No problem with that. So that is the case for algorithm design or algorithm writing. Like that you can actually use. Next, after designing the algorithm, you need to actually, then you have to actually analyze that particular algorithm. So for analyzing one particular algorithm, there are 2 main criteria to analyze the efficiency of an algorithm. That I have said that. So whatever you write, whatever you actually design one algorithm, that must be analyzed in terms of efficiency, or otherwise it has no meaning. So how efficient your algorithm is, that is the main actually part of algorithm. So there are 2 main criteria. One is time, and the actually second one is space. Time means time taken to actually execute the algorithm, not the code. Actually, programming purpose, it is not like that. Look, time means there are this may be actually confusing. Time means not like that. How much the code is taking for actually CPU time. So actually here for this time is not like that. How much time it is taking for the CPU. So that is actually different kind of things. So here this time is meant that it should be represented actually through some kind of actually input size. So it is actually one kind of abstract type of actually time. That is not the actual time. That means that it is not like that how much time it is taking for CPU or like that. This time is actually here time complexity. That means it needs to be represented